In this video, we'll begin to look at Chapter 5, Section 3, Solving Systems of Linear Equations by Elimination. And there are really three levels to this, three levels of difficulty to this type of problem. And so we're first going to see that if we were to add the two equations together, we get another equation that has the same solution as the above equations. This is just an algebraic fact. If we were to add the two equations together, so we can add 3x plus 3x and we get 6x. Then 2x and negative 2x is 0, so the y terms are eliminated there. And then 4 and negative 4 gives me 0 there. So dividing by 6, I get x is equal to 0. Now, so I've solved for one of the variables. Then what I'm going to do is I'm going to take that value and plug it into either equation, but I'll use the first one just so that it's easy to remember. We'll plug in x equals 0 and we'll solve for y. So we get 2y is equal to 4 or y is equal to 2. And so now we have a solution of x is 0 and y is 2. Next thing that we're going to do is we're going to use the second equation to just double check to make sure everything works out correctly. So 3 times 0 minus 2 times 2, and we want to know, does that equal negative 4? 0 minus 4 equals negative 4, and that's true, so we have checked to make sure that the solution to this system of equations is 0, 2. Now the next level of difficulty with this type of problem is shown here. We can't simply add the equations together and have one of the variables be eliminated. So we're going to have to do something. What we want in order for one variable to be eliminated is we need the two x terms to be the same value or have the same coefficients, the same number multiplied in front of them, but to have opposite signs. So here we can either try to make the negative 5x to become a positive 10x, then it will be eliminated, or we can make the positive 3y become a positive 6y. And I'm usually going to select or use the smaller numbers since that is easier to work with in general. So I'm going to multiply the top equation by 2. Why did I do that? Because when I multiply 3y by 2, I get 6y. And when I add 6y with negative 6y or minus 6y, in the second equation, the y's will be eliminated. So I'm going to multiply the top equation. That gives me negative 20x plus 6y is equal to 2. Second equation, negative 5x minus 6y is equal to 23. Now when I add down, I get negative 25x is equal to 25. So x must be equal to negative 1. All right, now I'm going to continue to do the same thing I did previously. Once I have one value, I'm going to take that value and plug it into the first equation. So negative 10 times negative 1 plus 3y is equal to 1. That gives me 10 plus 3y equals 1. Subtracting 10 on both sides, and I get 3y equals negative 9. So y must be equal to negative 3. So I have a potential solution of negative 1 comma negative 3. The next thing I'm going to do is use the second equation to check these results. Negative 5 times negative 1 minus 6 times negative 3, and I want to know if that is equal to 23. Negative 5 times negative 1 is 5. Negative 6 times negative 3 is positive 18, and we do in fact get 23 is equal to 23. And so there we go. So the first type a problem, we can simply add the equations together. One of the variables will be eliminated. The second type of problem is that we'll have to multiply one of the equations by a constant in order to get one of the variables to be eliminated. We'll go on to look at some examples of these. All right, so we have three systems of equations here. With the first, we see that we can simply add down and one of the variables will be eliminated. So when we add the two equations, we're going to get 6y is equal to 12, which means that y is equal to 2. We're going to take that value, plug it into the first equation. So 3x plus 2 times y, which is 2, has to equal 7. 3x plus 4 equals 7. Subtracting 4 from both sides, gives me 3x is equal to 3, or x is equal to 1. Now, I have an x and a y, so I'm going to record my solution. X is 1, y is 2. Then I'm going to plug them into the second equation to make sure that it all works. Negative 3 times 1 plus 4 times 2, does that equal 5? Negative 3 plus 8 does indeed equal 5, and that checks. All right, with the second equation, or the second system of equations, I can't simply add the two together. I'm going to have to multiply either the top equation by positive 3 to get rid, negative 3 to get rid of the x's, or I'm going to multiply the bottom equation by positive 3 to get rid of the y's. And since they're both by 3's, I'll choose the bottom since that doesn't involve negatives. And when I multiply, I'll bring down the first equation again. X minus 3y is 24. 3 times 3x is 9x, plus 3y. 3 times 12 is 36. When I add then, I get 10x is equal to 60. 10 times 6 is 60. And we're ready to plug that into the first equation. 6 minus 3y is equal to 24. Subtracting 6 on both sides, we get negative 3y is equal to 18. Dividing both sides by negative 3, I get y is equal to negative 6. So it appears that my solution is x is 6, y is negative 6, but before I can be sure, I need to check that in the second equation. 3 times 6 plus negative 6, does that equal 12? We get 18 minus 6, and that is indeed 12, and so it checks. With the third set of equations, again, I'm going to either have to multiply the top or the bottom by a negative 4, and when I do, I get, bring down the first equation, x plus 4y is equal to 22, and then negative 16x minus 4y is equal to negative 52, and adding down I get negative 15x is equal to negative 30, so x is equal to 2. Substituting that in the first equation, 2 plus 4y is equal to 22. Subtracting 2, I get 4y is equal to 20, so y is equal to 5, showing me that my solution is apparently x is 2, y is 5. I'm next going to check that in the second equation. 4 times 2 plus 5, and see if that equals 13. Gives me 8 plus 5 is indeed 13, and so that checks. All right, then in word problems related to this. A business with 2 locations buys 7 large delivery vans and 5 small delivery vans. Location A receives 5 large vans and 2 small vans for a cost of $235,000. Location B receives 2 large vans and 3 small vans for a total cost of $160,000. What is the cost of each type of van? So we'll let X be cost of small van, Y be the cost of large van. All right, so we know that location A buys 5 large vans, so that would be 5 times the cost of the large vans, and 2 small vans, and their total cost is $235,000. Location B buys 2 large vans and 3 small vans for a total of $160,000. Now, we have a system of equations. We can't just add and we can't just multiply one of the equations. I'm going to use the 2 and the 3 to make them 6. I'm going to multiply the top equation by 3, the bottom equation by -2. When I do, I get 15y plus 6x is equal to 3 times 235,000 to give $705,000. For the second equation, when I multiply through by -2, I get -4y minus 6x is equal to -2 times 160,000, which is -$320,000. Now I can add down and I get 11y, 11y, yes. The x's are eliminated. When I divide both sides by 11 then, I end up with y is equal to $35,000, which is the cost of the large van. Now I'm going to take that number and plug it into the first equation, which says 5 times y, which is 35,000, plus 2x has to equal 160,000. Well, 5 times 35,000 is the first equation is 5, y plus 2x is 235,000. So when I multiply 5 times 35,000, I get 175,000 plus 2x is 235,000. When I subtract 175,000 on both sides, I end up with 2x is equal to 60,000, and so x is equal to $30,000. So that would be the cost of the small van, $30,000. Now, just to make sure this is true, I should plug them both into the second equation. When I do, I get 2 times y, which is 35,000, plus 3 times x, which is 30,000, and that should give me 160,000. 2 times 35,000 is 70,000. 3 times 30,000 is 90,000, and that does indeed equal 160,000. And so my values check, and that is an example of a word problem that we could solve using the method of elimination.